So far we've mentioned these a lot, but we are going to spend a little bit more time talking specifically about our accessory organs, the liver, the gallbladder, and the pancreas. So our accessory organs, as you can see, are going to be attached to organs in our digestive system, but they, again, remember, are not part of that duct, that tube that runs from your mouth down to your anus. So remember that food never travels to your accessory organs. They're going to provide things that help us with breaking down that food and absorbing that food, but food never travels to those organs. So let's start with our liver. And our liver, we know, has a lot of different functions, and our liver is pretty darn important. We're going to be talking again and again about our liver as we look at different nutrients and nutrition. But manufacturing is part of what your liver does. So it manufactures and processes nutrients. So carbohydrates, that's our CHO, proteins, and fats. And so a lot of things that are going to need maybe a little bit more processing are going to go to your liver. So for example, our body really doesn't use any sugar except for glucose. So we're going to see that we might have broken things down to the point that maybe we have a fructose, a fruit sugar. And that is something that gets absorbed into your bloodstream from your intestine, but our body can't use it. And so it actually goes to our liver to be processed. We're going to manufacture things. So we're going to take things apart during the digestion process, and now we need to put them back together to create new things that your body needs. So proteins are a great example of that. We took our amino acids from our proteins that we ate, and now they're going to go to our liver, and your liver is going to say, hey, I need an enzyme, I need an antibody, I need to build some muscle. So we're going to create new proteins from those pieces. Our liver is going to synthesize bile, and we're going to talk more about bile in a second, so hold on to that thought. We're going to synthesize plasma proteins, so all sorts of proteins that we need to carry things in our bloodstream. Our liver does an awful lot of work detoxifying. So it breaks down alcohol that we need to detoxify. It breaks down and detoxifies, chemicals that we took in from food products or other things. Even too much of good things. So it detoxifies if we maybe took in too much vitamin A. So we're going to release a number of unwanted substances that travel with bile to the gallbladder, then to the small intestine, and eventually into the large intestine for excretion. So it's going to help us get rid of a lot of things that we've gotten from things that were in our bodies. Storage site for glycogen. We're going to come back to this again when we look at carbohydrates, but glycogen is going to be our storage form of glucose, and one of the places that we store that is in our liver. So the next organ is our gallbladder, and this is going to attach to the underside of our liver. There's a little duct that goes from the gallbladder, or from the liver to the gallbladder, and that is going to be how we're going to get that that bile that we made in the liver to our gallbladder for storage. So it concentrates, stores, and then as needed, as the signal comes from your small intestine, it's secreting bile into your small intestine. So bile, we've talked all about it, but it basically acts as an emulsifier. So it's going to help to keep fat in solution. Think of salad dressing. That's probably what you know as an emulsifier. If you have some like oil and vinegar, just oil and vinegar plain, and you shake it up, it stays together for all of about, 5 seconds before it starts to separate out. If you put something with it to keep it in solution, so, an egg yolk or other things, then your salad dressing will stay together with that oil and vinegar. So because there's a lot of water in your intestine, we need to have something to help that fat stay in solution. So bile is released through the common bile duct into the first segment of the small intestine. So what happens if you don't have a gallbladder? Well, the cool thing is that you can still make bile. Your liver still does its job, and we just don't have the ability to store as much. So we're going to have an attachment directly from the liver to the small intestine. So we can still break down fats. It's just that sometimes we have to eat a little bit lower fat diet, especially initially. And then the last of our accessory organs is our pancreas. And for our purposes in the digestive system, we're really looking primarily at those exocrine secretions. A lot of times we call it pancreatic juice. And that's our bicarbonate that we talked about that we need to neutralize our acid coming from our stomach. And then the enzymes, and there are lipases that break down lipids, proteases that break down proteins, and amylases that break down starches, that again, when we have that small intestine that senses what's there, it sends out the message and your pancreas responds appropriately. So your pancreas is not necessarily going to produce a protease if you ate something that really doesn't have protein. So our body is very adaptive and very good about giving what is needed at that time. We're not going to spend a lot of time talking about endocrine secretions at the moment. We'll talk more about those when we look at carbohydrates, but these are hormones. And hormones, of course, are going to regulate what happens. And we're really looking primarily at insulin and glucagon, which help us to regulate our glucose levels. So again, we'll come back to those when we talk about diabetes and our carbohydrate metabolism. So this is going to conclude our journey through the digestive system. And hopefully this has been helpful to see kind of how everything fits together and how we take that food and get it into nutrients and then get those to our body cells where we can use them.